Wonderful evening, and I'm pleased to be here for today's webinar, the Great Amrita Alumni Conclave, a full-fledged virtual webinar series led by the Amrita's most distinguished alumni. They will lead the session with an extensive knowledge of the futuristic scope and opportunities. And today, we are joined by one of our most illustrious alumni from the Bangalore campus MBMS program, Mr. Sachin Muralidharan Warrior, who will discuss on the topic blockchain and the future business. Sachin is a data scientist with an 8 years of experience working in the companies in the manufacturing, edtech, and fintech space. Sachin is experienced in all the areas of a data from a data warehousing, analyzing to build statistical and machine learning models in productions and communicating results to the stakeholders. Sachin in past assignment has been responsible for 53% sales by the dormant customers and preventive maintenance initiatives for a Fortune 500 construction equipment company. Currently, Sachin is responsible for maintaining the data stack at Vault and building the data science strategy. Sachin also works with the product and growth managers to help in data-driven product strategies. Sachin is an engineer graduate in electronic and communications from QSAT. He holds an MBA from an Amrita Vishwa Vidyapeetham and MS in Business Analytics and Systems from the sunny Buffalo. And Sachin is a passionate about fintech, teaching, and data science. Over to you, Sachin.
Thank you, Sebastian, sir. Thanks for the wonderful welcome and that introduction. It's really great, and I feel really fortunate to be returning back to my alma mater, although in a virtual form. It's great to return to your alma mater and be able to present something for all the alumni and future students who are gearing up to start their MBA journeys with Amrita. So without further ado, let me take a deep dive into our topic. So I'll be talking about blockchain and the future of business. So I'm a data scientist by profession, but I also am a blockchain enthusiast, and I currently work in the cryptocurrency blockchain space, mostly in the decentralized finance space. But having said that, I will not be talking about again, I do not want to promote any cryptocurrency or give any financial advice, since we are talking about a very volatile asset. But however, we'll cover a lot of different applications of blockchain that are uh, currently proof of concepts or some of the use cases that are already existing. Um, we might cross over some of the cryptocurrencies, but we will not talk about it as a financial asset, rather as an enabling technology of sorts, right? So moving on to the agenda for the day, we'll discuss a bit about what a blockchain is, what is the meaning of a blockchain, what is this technology all about. We'll talk about decentralization and the new version on of the web that everyone is talking about so much today, the Web 3.0, and we'll also try to see how that is different from the web as we have known it or as we know it today. We'll then talk about some of the blockchain applications in business. I strictly want to restrict it to business. Like I said, I will not be talking about cryptocurrencies. Then we'll talk about blockchain and big data that I cannot leave out because myself being a data person, and I think the biggest fortune we have had with Web 2 has been the generation of data and the ability to analyze it. And we'll talk a little bit about how that trend continues into the Web 3.0 world. And then towards the end, we'll talk about what opportunities the Web3 and blockchain have in store for India as a country, as a developing economy, right? Um, so to begin with, let's talk a bit about what the blockchain is. So the blockchain typically is a digital ledger, to put it in very simple terms. So if you if you know of ledgers, if you know about financial account keeping, financial record keeping, you would think of a simple kirana store, a simple grocery store that is on your street. That person would typically, if he's a small kirana store, he'd keep a record book as a ledger. He would have all the credits and debits written on like two sides of the page. And he'll probably have all records of the goods that he received from a distributor. And he'll also have records of the goods that were sold to the customer. Now, think of the same scenario if that was to be digitalized. It Number one, the data would have to be secure. It would have to be encrypted. No one gets to access that info. That data stays confidential and is only shared with parties that need to see those records. And think of the data being on a peer-to-peer network. So what I mean by a peer-to-peer network is that uh, in a typical scenario, in a typical record bookkeeping, you would have the store owner has his own ledger where he has some credit and some debit. Similarly, the distributor and also the customer would have some record of that transaction having gone through on their own individual ledgers. Now, that is the process that the blockchain tries to uh, do, but in a digital format. Um, now, Now this also enables easy data sharing. Now, this data sharing doesn't mean that everything is like readily accessible, but it basically means that data is available to cross check, to verify, to validate, and to audit every transaction that has happened. And also the system is decentralized. So now typically if you take a web 2 situation, if you look at how technologies have evolved in the past decade, we would see that a lot of the record keeping that was traditionally kept in ledgers, in record books, has transformed into server based technologies. Today we are all talking about the cloud, but the cloud comes with a limitation where probably your own store and the store which is 100 meters away from you probably uses the same Oracle or Microsoft technology, and the data is all stored on the same cloud, right? With decentralization, you remove that. Your own mobile, your own laptop acts as a server on its own, and you can basically keep a record of every transaction that you have done, provided your vendor and your purchaser, your customer, is also on the same decentralized network, right? So that's what a blockchain is in terms of architecture. Now, how does a transaction typically work in a blockchain? Now, of course, here I'm stating a Bitcoin example. I mean, the infographic shows Bitcoin, but however, let's just keep Bitcoin out of the equation for now. Think about a single transaction. Now, a transaction is made, and that transaction has to be authenticated in order to ensure that the transaction has gone through between uh, the store owner and the distributor. Now, what happens is uh, there is a block of information. A block is nothing but some encrypted data that represents that transaction having gone through. Now, that block is sent to every participating node in that decentralized network, and every node validates the transaction. Now, if every node validates and says that, okay, this transaction is correct, this transaction is legal, then uh, you receive the validator receives a small reward for the auditing that he has done, and a new block is added to the entire history of all transactions that has taken place on that decentralized network. Now this is updated across the network, and the transaction is considered as complete. Now this is a very long process, but the whole idea of having this process in place is to ensure that every transaction is visible, is transparent, and is highly secure, right? Now, moving on. So we already spoke a little bit about decentralization, but how has this changed over time? So, uh, so today, one of the biggest game changers in the Web 3.0 space, of course, the Web 3.0 is today is considered as a very large goal where we are talking about augmented reality. We are already hearing about the metaverse and Microsoft's own Meta projects, but a very huge chunk of this also comes from decentralized applications. Now, decentralized applications are nothing but mobile apps or uh, desktop apps that act as a node in itself, and that can become part of this decentralized network. Now, these dApps are automated. They use smart contracts. Now we'll talk about smart contracts a bit more as we go on. And these typically run on a decentralized network of systems, right? Now, like I mentioned earlier, each device has its own ledger. It has its own store of data in the form of blocks, and uh, it each of those blocks, each of those ledgers validates every other transaction that is happening and keeps adding the data in the form of these blocks, right? Now, another infographic that you'll see on your right side is typically the history of the web. So when we talk about the World Wide Web, somewhere in the 90s, probably when I was a kid, I don't know about many of you, many of the audience might have seen this phase where we had basic HTML pages. We had a very basic Hotmail account or a Yahoo Mail account, where you could just send emails, or you could just type a web address and you would see a very static kind of web page, right? So that is where we started when the web had started. This is what we were seeing. And then over the past 1 or 2 decades, these websites became smarter. You now have multimedia content. You have cookies that track the user behavior. You have analytics. You have APIs that stream data for you, and it has become the whole game changer has become the generation of information and collecting information on a centralized server, right? Now that is changing with time as we move into the 2020s. You'll see more user centric applications. Every user has his own application on the internet, but every user becomes his own server, by which everything becomes more decentralized, more private, and secure. Moving on, now I want to explain typically how this decentralized network works, and basically how does the data flow through the network, how is it validated, and uh, how different nodes contribute to that process. So what you see here on the top left, you'll see a typical chain of blocks. Now, the first block that contains data is called the Genesis block. It probably doesn't contain any data. Uh, it's just the first block that initiates the whole data collection process. Now, that particular block would have a hash. The hash is nothing but a encryption of the data that it contains. So typically, there are algorithms that are used, MD5, SHA 256. Most blockchains use SHA 256 or some variant of the same, right? Now, as data grows, as the network keeps adding transactions, you'll see that more blocks. So the block 2, the block 3 get added, and these basically have a record of what was the preceding block. And typically one chain of blocks represents particular order of transactions. So it is actually keeping a record, a history of every transaction that has happened within a particular network, right? Now, this block, each of these blocks, each of these hashes can be a combination of user information, or any underlying conditions, or any underlying data that needs to go on the block. And these blocks can in turn be connected to a traditional database where you have much more information about different transactions happening. Right now, what you see on the right side, you see the orange and red blocks. Now, this is the case of validation. So you see that peer one has been generating blocks, and you see that the orange and red blocks are fraudulent. So what happens is the orange block is a fraudulent block that is identified, and peer 2, peer 3, peer 4, and peer 5 on the same network validate it and find that it doesn't match with the ledger records that they see in terms of the transactions that they've had with peer 1, or one of the peers might have had a transaction with peer 1 and the others are validating the same, and they find a mismatch, in which case that block is termed as a fraudulent block, and that is cut off, and the peer one is overridden by the actual sequence of events. Now, this is a mechanism by which the blockchain ensures that there is security. If suppose peer one is hacked and a hacker now inserts some irrelevant information or tries to pull some information, that also becomes a record of this blockchain, and you can actually do some faults. I mean, you can find the fault in the chain and eliminate the effects of that. Right now, again, the next figure also conveys the same thing. So basically, it talks about how the transactions are processed. And if you look at the point number 5, you see that the pieces of the puzzle are keeping on adding up, which basically means that it is uh, keeping on adding new blocks. And these blocks are basically, you can add a block, but you cannot remove anything. So it's ineditable, and very transparent in that sense. So now, so now let's come to the core of this. So when cryptocurrencies and blockchain was started off, people were looking at this mechanism which is called consensus. So basically, when peer one does some transaction, peer 2, peer 3, peer 5 might be forming a consensus on the same transaction, hence the terminology consensus. Now, what happens in smart contracts? So smart contracts is the evolution of the whole blockchain system. The blockchain technology has been around for a while, but not predominantly used. But what changes things today, and what makes a huge impact on how it would be used in business, is the evolution of the smart contracts. Now, smart contracts are nothing but these are programmable. These are programmable contracts, or let's just say they are computer programs or protocols that automate the process of execution. So if a node is running a smart contract, it is an automated thing. It controls and documents every legal contract, every legal term that is part of a consensus that needs to be uh, arrived at, right? So so think of a scenario where you want to purchase something, or let's just say that you want a service being done. Let's just say that you want your house to be painted by a painter. Now, let's say that you use a DApp. So let's just say that you have something like Urban Clap, but which is now a decentralized Urban Clap application. And you would basically give a contract to the painter, asking him to complete a job. Now, uh, you would basically pledge, let's say, some Ethereum or some token, some amount of money to that painter, provided he completes the job on time, right? Now, basically, the network will try to come to a consensus whether, number one, whether you had pledged a certain money, what was the terms of the contract for which you pledged the money, and number two, did the painter do all the things? Did he bring in the right raw material? So every raw material might be scanned, every raw material's barcode might be registered. Maybe there would be some monitoring of the paint job by a supervisor who also has a DAP. He would make an entry, and only when the entire chain is complete, the Ethereum that you had pledged to the painter gets released and goes to that particular person's Ethereum wallet, right? So every other machine that is part of this particular DApp network is verifying whether each of these happened. Now, how does this help? It basically adds an element of trust to the transaction. It reduces any fraud that can happen. So you could cheat the painter or the painter could cheat you, but it keeps it ensures that um, there is no loss, and it also reduces all the manual effort, the paperwork that is involved. Now, a simple example of a smart contract that we have known probably for the past 2 or 3 decades is, think of a soda vending machine. Now, the soda vending machine works on a very simple principle that you have a software installed, and the software probably contains some amounts. So it might say that Coca-Cola costs 20 rupees and Sprite costs 30 rupees. Now it already knows that, provided you click the right button for Coca-Cola and you present the right 20 rupee note, it's gonna give you that bottle of cola, right? So a soda machine can be thought of as a standalone smart contract of sorts. But what we are talking about today is a more distributed, decentralized approach of the same. Now let's move on. Let's talk a little bit about uh, the blockchain applications. So there are a lot of applications that people are trying to find solutions to and trying to adopt the blockchain for those. And one very popular one, and something that uh, has been used, uh, for a while now. Probably a lot of people uh, are talking about this, and this is probably one of the earliest problem statements that people have tried to solve, is that of the supply chain. So you can think of how a current supply chain works. You have products shipped. You probably have one ERP software so at every point you scan a barcode. The barcode is sent to a centralized server that sits with maybe a Walmart or a Target store or a Big Bazaar in India or a DMart something. And at every stage, the barcode is scanned. And towards the end, when you receive the product, you know that, okay, so finally there is a scan at the inventory, and that goes to your stock, that goes to your inventory. Now, IBM has revolutionized this process. They've added a few more additional components. They've put the transactions on the blockchain. So now what Walmart has enabled is that um, at every stage, you can also, so you of course have the barcode scanned. You can identify every point that the thing has passed through. And not only that, the quality of the fruit or the meat that is being transported can also be checked. And at every stage, a new block is added to the network. And every block will have information about uh, what is the product, uh, what is the current state of the product, where is it currently, uh, and every other shipping detail that is available, right? So think of this. To put it in infographics, you have a farm, you have some apples picked. Now you have that loaded. Now each of those processes has a block created. It goes to a manufacturing plant. The apple comes out as, say, a puree or a jelly or something. It is packed, it is bottled, it is loaded again, comes to the Walmart distribution center. unloaded, loaded, and then it finally comes to the retail store where it is sold. Now, each of these is marked, each of these is created as a block on the IBM Food Trust uh, technology. And this is currently hosted on something called as a Hyperledger, which is a Linux-based Linux-based store of sorts where you can host these private blockchains. So this is an example of a private blockchain. This is entirely owned by IBM and Walmart. It's a joint venture. But there are also public blockchains like we discussed earlier, where you might be on the Ethereum blockchain or the Bitcoin blockchain, which is open to all, right? Another example, another variant of IBM Food Trust is IBM TradeLens. This is used currently by one of the big uh, logistics company, Maersk. They again have a joint venture with IBM on this, where again every shipment is scanned. Uh, every shipment has a smart contract. Every stage is tracked, and basically there is no paperwork. All the paperwork is in the form of smart contracts on the blockchain. Now, another very interesting use case of blockchain, which was quite surprising to me, was this company called Follow My Vote. So they're enabling digital voting. So now, typically, yes, we come from a country where we have probably been doing digital voting for, I don't know, the past 10 or 15 years. But many countries even today use a lot of ballot paper based voting. Uh, Maybe not in the government, at a government level, but at least in organizations and institutions, you still see a lot of paper voting. And probably even in India today, we have a lot of paper voting that happens. Now, Follow My Vote is a blockchain based voting system where every user can basically install a voting booth software. It's another distributed app. It's another DApp, and they can cast their vote. Uh, of course, after authenticating, they'll have to give a a national ID like your Aadhaar or your passport. They have to register for that particular university election or institution election. They can cast a vote um, with whatever signature, a digital signature or a thumbprint scan that they provide. And this basically becomes part of the blockchain. Now, what is interesting here is that the election would have a deadline, and the user is allowed to make up his mind until the deadline. They can edit their vote, they can change the candidate that they picked, and all these alterations are tracked on the blockchain. So it also helps in further understanding the, kind of getting analytics of, why did a particular user choose a particular candidate and then later change their mind and finally a particular candidate won, right? Unlike a traditional election that happens today. So that is how blockchain is revolutionizing the voting space. Those are two great examples from like business and politics, or operational things. Now let's talk about something more fun. So people are trying to find out ways of using blockchains as a mean of entertainment, how to use blockchains in entertainment. Now, a big part, although we associate music as entertainment, we associate television or movies as entertainment. It's a very big business that happens in the background. Now, many of you might have come across recent reports about Spotify not paying the right amount of royalty to a lot of artists, and that has actually created a big ruckus. And a lot of people early into this year were actually removing their albums from Spotify. Now, there are some startups that are trying to solve this problem. So if you look up these startups like Mycelia, Voice, and MusicCoin. These streaming services, they allow an independent artist, an independent musician to host their work on their platform on their blockchain, um, and using their particular dApp. And what happens is the ownership to that whatever they upload doesn't lie with these dApp companies, but it lies with the artist himself. Now, the metadata is embedded. It is sent. The the smart contract is created. Now anyone can look up that piece of music. They can play the music, and for uh, every play that you do, the user, as a user, if you're someone who's streaming the platform, you probably have bought some tokens. uh, so by token I mean something like a cryptocurrency. You would have bought that currency for, as a subscription, or every month you get certain currencies. Now those currencies, you pay to this platform. Through the platform, the currency is passed to that particular uh, artist, right? Now when I say through the platform, I do not mean that there is a centralized server for Voice. It means that there is a network that verifies this and ensures that the money reaches the artist uh, based on the number of times that the music was played, right? So this is solving a lot of issues with, with who owns the rights to certain music, to certain videos, etc. Right now, of course, there are music NFTs. So there's a link. I don't know if I'll be able to open the link. Um, so this is a small link. I mean, this is just a tweet that a very popular DJ called Steve Aoki had made. This is basically a NFT where you have a background music and you have a video. Now you could own this if you're ready to pay that artist for whatever he charges. Currently it has probably passed down a few different times. People have auctioned it multiple times, and today probably it costs a few $1,000s, right? So that's again about NFT. So we'll talk about more about NFTs in a bit. Um, Again, I want to keep it towards the end because although it is, there is a business involved in it, I'll probably talk about towards the end, because there are many more other businesses that, use blockchain more effectively. Another another interesting application. This again is a proof of concept. It's something that is still being worked on. There's probably a small prototype that has been tested on maybe 5-10 cars by Bosch. So what Bosch does is they have something called their Internet of Things lab. They take odometers. They basically embed these odometers that have some telemetric equipment. They have sensors that keep a record of the different odometer readings from time and again. Now, what typically happens is that sometimes when you're taking your vehicle for servicing, or you're trying to sell off your vehicle, you might try to manipulate the odometer and uh, try to get a fair price, sorry, a better price than the actual fair price. Now, Bosch is trying to solve that problem. Bosch wants to ensure that the price paid for every vehicle is the exact price, is the depreciated value based on the age of the vehicle and the telemetrics that you get from the odometer reading. Now, how does Bosch do this? The car, or the sensor embedded into the car, uh, in itself is a DAP. Now this DAP is transmitting signals every now and then, and this signal is being captured by the blockchain. Now the entire blockchain has a record of every odometer reading from between a certain interval of time. It has kept a odometer reading. And now if someone suddenly uh, changes the odometer reading, takes it down by say 1,000 kilometers, uh, the consensus algorithm, the validators can now verify this and basically report this as a fraudulent block. And you can now take action on whoever that owner or someone related to the owner or uh, the salesman who might have tampered with the odometer, because you have a clear record of the history, right? So this is how Bosch IoT Labs is doing it. They currently have done it on very few number of cars, but in the future they plan to make it a, a more viable solution, a much more faster solution that can ensure that this type of odometer fraud doesn't happen in any car, right? Now, of course, we did talk about smart contracts, and again, as you can imagine, since there are contracts involved, it can also be used to save a lot of time and cost in the legal space. So how are people using it? People are using this for mortgages, intellectual property, chain of custody, uh, basically to establish authority of different properties. And what happens in this space is that you have a certain property that you own. You probably today have a paper document. The paper document with the particulars of every property, every asset that you own, basically becomes codified, or any financial things you might have pledged the property for mortgages. So that property is recognized as collateral, the money is released, and you basically have a record of this being put on mortgage on the blockchain. Now, as you pay back, or as there is a transfer of ownership, say maybe from the bank back to you or from you to someone else, uh, all these records are kept on the blockchain. And each of these, so based on the ownership of it, these can have some digital signatures associated with the entire transaction that's going on. So taking that one step further, this what you'd see again. I was probably talking more about assets and properties, and the same thing. Probably the biggest industry that gets a lot of help from the legal framework of smart contracts is the real estate. So there are some statistics from 2013, late 2013, where they say that in big cities like Delhi and Mumbai, there are about 170 to 180 real estate frauds that happen annually. Now, I'm pretty sure that most of you would have heard of the real estate frauds that have happened in Delhi, right? There are still a lot of buildings that were pledged to people. They have still not completed the entire project even after so many years, right? Now, the state of Andhra Pradesh, they, of course, with the help of a startup from Sweden, they have come up with a real smart solution, a blockchain based solution, uh, to avoid these kind of real estate frauds. Now, what do they do is they have the Capital Regional Development Authority. They have their own private blockchain platform, where they keep they keep property records and ownership details of every property that exists in that area. Right now, I think it is largely based in Amravati. So most property in Amravati has been codified and stored on the blockchain. Tomorrow, if any of those properties sold, the ownership changes hands, uh, the government would have a clear record of that, and there will not be any paper-based, there won't be any paper-based proof. Rather, all the legal terminologies of the transaction, of the lease, or of the transfer of ownership, are all going to be present on this on as blocks on the blockchain, right? So this is how real estate is revolutionizing, and this is actually a real problem because um, today, if you go to many small towns in India, you'd actually find that there are so much property that has not been, the ownership has not been transferred, or there is a huge delay in the transfer of ownership, and eventually papers get missed. There's a lot of trouble, and then there are a lot of legal follow-ups that need to be done in order to ensure to establish the ownership of a particular property. So this can eliminate those kind of confusions to a great extent. Now, this is one of the most interesting topic. Uh, this is something that I have personally been investing a lot of time in. So blockchain in healthcare is a very big topic in itself. Now, think of a scenario where, let's say, you are traveling on the road, you meet with an accident, you have had a, 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 a major concussion, you do not remember anything, you do not know if you are diabetic, you do not know if you have blood pressure, you do not know if you're allergic to some antibiotics, you do not know what your blood group is. Now imagine all of this could be digitized, uh, could be codified. Uh, However, um, and a lot of big fancy hospitals do keep a record of this. But let's just say that you meet with an accident and all you have nearby is, say, a small government dispensary, right? You have been you have been going to Manipal and Apollo all these years, and suddenly you find yourself injured. You probably don't remember what just happened, and you have a broken leg or a hand. You need treatment, or you have lost blood. You need a surgery, and all you can find is a government hospital nearby. Now, if healthcare is on the blockchain, uh, the blockchain would have every record of what all treatments you have been through. It would have every record about your, your blood pressure, your sugar, what kind of medicines have you been taking? Are you allergic to anything? How is your overall fitness? All these things can be available on the blockchain as individual blocks, and it can keep updating. So uh, maybe 6 months before you had a record on the blockchain, uh, today or as of yesterday you might have had another follow-up with your doctor, and that record also becomes part of it. Now you basically have a few years of history about your healthcare, and that will help the government doctor who's now looking at you. He doesn't have to run a bunch of different tests to establish a few things. He can immediately take a record of your blockchain, verify it, and put you into the operation theater and mend your wounds. Right now, of course, a larger opportunity in this is that these can be integrated, or your wearables, your IoT based diagnosis event devices can now be integrated into the blockchain. These devices can now start generating new blocks onto the blockchain, and not just hospitals, but even insurance companies can make use of this data, and they can propose um, better insurance plans, cheaper insurance plans to you, right? So that's how blockchain can revolutionize the healthcare industry, right? Now, that's all about business, right? But let me now talk about the biggest business that blockchain was involved in the 2021. 2021 officially, at least in the tech circle, is known as the year of NFTs. Now, what are NFTs? NFTs are like digital art. Uh, so think of the Mona Lisa, right? Uh, what is the difference between the Mona Lisa uh, and a painting that my 5-year-old niece drew yesterday, right? For some reason, I'm no expert in art, but you would notice that for some reason, the Mona Lisa is very attractive. It has passed down. It has The ownership has passed down through generations. Different people bought it. There's something exciting about that painting, and everyone's everyone wants to own a piece of that painting, right? Now, the same is happening in the digital space. Uh, there might be people who are looking for branding, people who are looking for digital art as a source of branding. They want to use that logo uh, in their own personal brand. They might want to hold on to some very interesting digital art today and maybe sell it later for in exchange of money, or they probably want to keep it as a prized possession to to show off and to say that, hey, I hold a a very rare piece of digital art, right? Now, this is what NFT is all about. You could own a piece of digital art by making a payment. Now, of course, you might ask that, hey, why can't I just Google that same particular art um, and just download it and have it as my phone wallpaper? But the catch is that although you might use it as a wallpaper, you do not own it. You cannot sell it. You cannot get the best resolution of it. You cannot uh, manipulate or do anything with that particular piece of digital art. Now, how would you do that? You have to own it. You need the certificate of ownership. And the certificate of ownership is the smart contract, right? You have a smart contract. The certificate of ownership is the token that tells you that you are the current owner of this piece of art. And that ownership is probably passed from the artist to you. Now, tomorrow, if you sell that piece of art to someone else for, say, double the price or triple the price, now what happens to the artist, right? Does Leonardo da Vinci or Leonardo da Vinci's family or his, whoever his successors are, do they get a piece of anything that comes from the sale of Mona Lisa, say from some particular, let's say today France owns it. Let's say they sell it to India and India is ready to pay a huge sum for the Mona Lisa. Uh, would the family of Da Vinci receive anything? In the current situation, they don't receive any royalty. But with NFTs, let's say there was an NFT, there was a token that validated the ownership of Mona Lisa. Probably some successor of Da Vinci, whom he promised the ownership to, might get a share of the money that India paid France for that piece of art, right? Another example of this is this again is something that came through a LinkedIn post just a week back. The ownership of books, right? Now, now I could write a book and say I sell it for 700 rupees in the market today. Now, fine, the publisher might take, say, 600 rupees and he might give me 100 rupees as royalty, right? But the transaction, the ownership ends there. I might be the owner of the content, but once I sell that book for 700 rupees, the ownership now of that particular book lies with the person who purchased that book from me, from the publisher, right? Now, let's just say that that guy he read the entire book, he doesn't find it useful anymore, he decides to sell it to another person as a second hand book for, say, 200 rupees, right? Now, I do not get even one paise from the sale of that, or from the second sale. But if there is an NFT that backs the book, and let's say it is a digital book, it is a soft copy book that is being transferred uh, using a smart contract, uh, I would also continue to earn uh, some royalty from the second and the third sale of that very same book, right? So you never know, in the future you might even see this happening. Already a lot of books are going digital. uh, Tomorrow you might have royalty getting generated through the blockchain for some of these uh, for some of your textbooks or your uh, novels, right? um, so yeah, so that's how technology is transforming business and and the law. But okay, so all this said, there's a lot of data flowing through the blockchain. Um, it's technically generating huge amounts of data, right? There's so much big data that that is lying, but the structure of this data seems very funny. Everything is hashed. Everything is, there are records of this, but probably the records are very hard to comprehend, right? So now there are startups that are working in the space of trying to make this data, this big data, more comprehensive and easy to query, right? So there are two such technologies that are very popular today. One is called Graph and the other is called Covalent. Now, Covalent, surprisingly, is an Indian company. It is run by, of course, Indian people. Um, what Covalent tries to do is they currently have 14 different networks that they support. They have a single API. They have a single uh, programmable interface that can be used to query any of these 14 blockchains. And they're growing, they're adding one blockchain after the other. And tomorrow, probably in the next 2, 3 years, doing analytics, understanding better about these transactions in more detail would become a much more, a much more comprehensive task for business analytics and data scientists. And they can build some algorithms on top of that that can give a better understanding of how a certain business on a particular network is working, right? So wanted to touch about that being a data person and uh, uh, yeah. Now, what does this mean for India, right? So we are a we are a booming economy. Um, we have been in the ITES space for say the past 2, 3 decades. We have been a major player. Uh, Indian IT companies do a lot of service, a lot of outsource work, and that particular thing has opened up a lot of opportunities for us today. We are the future Silicon Valley. Bangalore and Bombay, Mumbai are creating a lot of startups that are working in this space, and we, with our strength in IT and ITES, which is essentially a low resource industry, we are creating excellent software, and we have already started scratching the surface of layer 2 solutions for the blockchain. So by layer 2, I mean solutions that make the blockchain more efficient, more comprehensive, more understandable. And India is playing a big role. We may not be creating blockchains of our own, but we are working on the service side of that. We are building new platforms on top of existing blockchains. And that is a great opportunity. Um, and cryptocurrencies and blockchain is a very new field, and there's a lot of potential yet to explore. We have only we have only seen the tip of the iceberg, but there's a lot of opportunity that still lies for India to uncover and make great use of. So that was my time. There's probably 6 more minutes left. Um, I'm open to questions. Um, yeah, that's all I had to say. And probably we'll see blockchain growing in India, and we'll probably see a lot many more from Amrita School of Business joining the forces, joining force with these IT players, building great blockchain solutions, uh, and yeah, would be great to see that happen. Thank you. Over to you, Sebastian, sir.
Thank you, Sachin. Thank you for. I don't see any chats, live chats right now. In-depth knowledge about the blockchain and its importance in the today's business environment that you could cover. And thank you so much for taking your valuable time and giving us Sachin. Thank you for adding more values to this great Amrita alumni.
Thank you. The pleasure's mine. It's good to be here.